مساء الخير يا ولاد. احنا المحاضرة بتاعتنا النهاردة عن الجلايكوجين ميتابوليزم. هنشرحها على محاضرتين. Okay, so this lecture is about glycogen metabolism. We are going to explain it on two parts. In the first part, we are going to explain the sources of blood glucose. We are going to remember the glycogen structure and the difference between the glycogen stored in the liver and the muscle. We are going to take the metabolic importance of glycogen storage. Why do our cells need to store glycogen during the well-fed state? What's the use of this glycogen? And we are going to explain the pathway of glycogenesis or glycogen synthesis and the pathway of glycogenolysis or glycogen breakdown. في الجزء الأولاني من اللكتشر زي ما سمعنا كده هنشرح ايه أهمية الجلايكوجين، ايه الجلايكوجين موليكول، ايه المكان اللي بتتخزن فيه الجلايكوجين موليكول، طب هي بتتخزن mainly في الليفر والماسل، طب ايه الفرق بين الجلايكوجين of the liver والجلايكوجين of the muscle، طب why do we store glycogen، ليه لازم نخزن جلايكوجين في السيلز بتاعتنا، طيب الباثواي بتاع السينثيسيس اللي هو جلايكوجينيسيس والباثواي بتاع البريك داون اللي هو جلايكوجينولايسيس. زي ما احنا عارفين احنا بندرس الباثواي عشان نفهم الامبورتنس الميتابوليك امبورتنس بتاعته in the body. فنفهم في النورمال ستاتس بيبقى ايه الاخبار، ولما يحصل alteration او اي enzymatic deficiency او اي genetic defect ايه الميتابوليك alteration وايه disease which will result from this error of metabolism. ده الفيرست بارت، ده الجزء الاولاني من اللكتشر. In the second part of the lecture, we are going to study the regulation of glycogen metabolic pathway, يعني regulation of glycogenesis and glycogenolysis, as we very well know that any pathway, any metabolic pathway has to be regulated in order to maintain our body homeostasis. In this case, we are studying carbohydrate metabolism, so we are the body aims to maintain a stable blood glucose constant, or blood glucose homeostasis has to be maintained all the time, whether during the well-fed state or during the fasting state, and this is attained by regulation of all metabolic pathways in order to be adapted to the well-fed state and the fasting state. Then we are going to study the related metabolic disorders of glycogen metabolism, or what's called glycogen storage diseases. ندرس بقى بعد كده glycogen storage diseases لأن هي دي related metabolic disorder of glycogen metabolic pathways. تمام؟ طيب الأول كده نفهم إيه مصادر البلاد جلوكوز، لأن دي مهمة قبل ما ندرس الجلايكوجين ميتابوليزم نبقى فاهمين البلاد جلوكوز بتاعنا إيه السورسز بتاعته. نراجع مع بعض كده. إحنا عندنا 3 main sources of blood glucose. We have 3 main sources of blood glucose. The main source is glucose of diet, of carbohydrate diet, and this is the main source of blood sugar during the well-fed state, of course. The second 2 sources are glycogen degradation and gluconeogenesis, and these 2 sources are attained or obtained during the fasting state. During the well-fed state, we have let's remember the glycogen structure because this is important. A glycogen molecule is a highly branched polymer of alpha D glucose. زي ما احنا عارفين ان المولكول بتاعت الجلايكوجين خدناها قبل كده في الموديول بتاع basic science 2 لما خدنا carbohydrate chemistry. قلنا ان الجلايكوجين molecule is a highly branched molecule of alpha D glucose. molecule highly branched وهي عبارة عن pure glucose. طبعا زي ما انتوا عارفين انه it exists as cytoplasmic granules موجود في كل السيل. Most of the cells contain glycogen cytoplasmic granules but mainly in the liver and the muscle. يعني معظمه في الليفر والمسل، نسبة قليلة قوي موجودة في بقية السيلز. Okay. Glycogen structure, if we took this part of glycogen molecule, which is a highly branched molecule, if you took a small part and magnify it, we are going to find out that a glycogen molecule is formed of 2 main types of bonds. So what's the metabolic importance of storing glycogen? Okay, let's say first the percentage of glycogen which exists in the liver and in the muscle. We have almost 1 to 2% of the muscle mass is formed of glycogen, stored glycogen, and nearly 10% of our liver mass is in the form of glycogen. Okay, but since we have much more muscle mass, so this means that our muscle store most of our glycogen molecules. يعني طبعا احنا عندنا mainly ان الجلايكوجين stored mainly في الليفر والمسل. تقريبا الجلايكوجين بيمثل 1 to 2% من المسل ماس و 10% من الليفر ماس. but طبعا since ان المسل عندنا البلك بتاعت المسل، لما نحسب كل المسلز الكتل العضلية اللي عندنا في جسمنا نلاقيها اكبر بكتير من حجم الليفر لوحده، فده معناه ان احنا العضلات بتاعتنا بتخزن كمية جلايكوجين اكتر بكتير من الليفر، though ان الجلايكوجين بيمثل في الليفر 10% من الويت بتاع الليفر و 1 to 2% من المسل، بس المسل البلك بتاعتها في التوتال بادي اكتر من الليفر، فبالتالي الجلايكوجين في المسل much more than الويت بتاعه much more than in the liver. تمام؟ طيب ايه الامبورتنس؟ what's the metabolic importance of storing glycogen? To provide a stored form of glucose that can be rapidly mobilized. يعني عشان يبقى عندي source of glucose مخزن اقدر بسرعة ان انا احوله لجلوكوز. انا مخزن الجلوكوز في صورة جلايكوجين، وده source سريع للجلوكوز، ده source يرفع لي البلاد شوجر بسرعة during the fasting state. Since diet is not a continuous reliable source، احنا مش على طول بناكل. we are not always taking glucose, we are not always taking carbohydrate diet, so there are times when we are fasting and we are not taking carbohydrate or enough carbohydrate in our diet, and so we need a continuous reliable source of readily available glucose in our body, and this is stored in the form of glycogen. So glycogen of the liver, especially of the liver, presents a readily available, rapid, reliable source of glucose during the early fasting status. This is the rapid responder, the glycogen, stored glycogen. Because gluconeogenesis, of course, is very important pathway. Gluconeogenesis is a very important pathway, but it is a slow responder. It takes time for gluconeogenesis to take place. So we said before that glycogen is mainly stored in the liver and in the muscle. What's the difference between the glycogen stored in the liver and the glycogen stored in the muscle? Muscle glycogen is for the muscle itself. طيب نبتدي بقى نقول what's glycogenesis. Glycogenesis means glycogen synthesis. Of course, we are going to synthesize glycogen from glucose. When does this take place? This will take place during the fasting state or during the well-fed state? Of course, during the well-fed state, because we need to have excess glucose to be able to convert it to glycogen. We cannot consume glucose while we are fasting and convert it to glycogen. We're going to store glucose in the form of glycogen when we have excess glucose, and this takes place during the well-fed state. Of course, under the effect of our well-fed anabolic hormone, which is insulin. Of course, insulin stimulates glycogenesis during the well-fed state. طيب يبقى glycogenesis معناها synthesis of glycogen from glucose. يبقى لازم يبقى عندي excess glucose عشان اقدر احوله واخزنه في صورة glycogen. الكلام ده يحصل طبعا during the well-fed state، وطبعا under the effect of الهرمون بتاع well-fed اللي هو مين؟ under the effect of insulin. ليه بخزن؟ عشان زي بحوش، يعني انا معايا فلوس كتير دلوقتي فانا هحوش شوية. هي نفس الفكرة، أنا دلوقتي واكل كتير well-fed، عندي enough carbohydrate، عندي enough glucose، فعملت already glycolysis وعندي excess، فواي نوت إن أنا أخزن في الليفر والمسل عشان أستخدمه at the time of need اللي هو لما أبقى في حالة fasting. طيب الأول كده نفهم إيه مصادر البلاد جلوكوز، لأن دي مهمة قبل ما ندرس الجلايكوجين ميتابوليزم. نبقى فاهمين البلاد جلوكوز بتاعنا إيه السورسز بتاعته، نراجع مع بعض كده. إحنا عندنا 3 main sources of blood glucose. We have 3 main sources of blood glucose. The main source is glucose of diet, of carbohydrate diet, and this is the main source of blood sugar during the well-fed state, of course. The second 2 sources are glycogen degradation and gluconeogenesis, and these 2 sources are attained or obtained during the fasting state. During the well-fed state, we have diet is the readily available source of blood glucose, and during the fasting state, we can break down our glycogen, our stored glycogen in the liver by glycogenolysis. And this is the fast source for maintaining blood glucose. And the second source, which is a rather slow source of blood glucose, which is the gluconeogenesis. يبقى عندنا مصدر سريع للجلوكوز اللي هو الجلايكوجين ديجراديشن، ده على طول أول ما بنصوم على طول زي ما شرحنا قبل كده، وبعدين بيتأخر بعديه شوية الريسبونس بتاع الجلوكونيوجينيسيس. 2 main pathways. These 2 main pathways glycogen structure. If we took this part of glycogen molecule, which is a highly branched molecule, if you took a small part and magnify it, we are going to find out that a glycogen molecule is formed of 2 main types of bonds. Okay. One bond is the straight chain bond here. As you can see here, the bond between this slide illustrates the UDP-glucose. And this is the reaction. You don't need to study this. What's the use of the glycogen primer? Glycogen primer is a very important molecule because this glycogenine molecule, our glycogen synthase enzyme cannot form a 1,4 glycosidic bond de novo. We cannot synthesize glycogen from the start. This enzyme cannot synthesize glycogen de novo. We need to have a glycogen primer in order to attach to it more and more UDP glucose and form our fully formed glycogen molecule. So we need this primer in order to attach multiple units of UDP glucose and form our 1,4 bond. يبقى عشان الجلايكوجين سينثيز انزيم ما بيقدرش ان هو يعمل جلايكوجين دي نوفو، يعني من اول وجديد، لازم يبقى البرايمر موجود عشان امسك معاه او اخلي more and more UDP glucose molecule تقدر تمسك وتعمل ال 1,4 bond. يبقى ده مهم قوي ان يبقى عندي جلايكوجين برايمر. الكيميكال نيتشر بتاعته هو جلايكوجينين هومودايمر جلايكوزايليتد بروتين، يعني هو عبارة عن بروتين هومودايمر 2 بوليبيبتايد زي بعض بالظبط وماسكين مع جلوكوز، فعشان كده اسمه جلايكوزايليتد جلايكوجينين. It serves as an acceptor of glucose from UDP glucose. زي ما اتفقنا انه من غير البرايمر مش هينفع ان احنا to build up الجلوكوز molecule de novo، لازم الجلوكوز يمسك في حاجة already موجودة. So a glycogen primer or glycogenine is very important to serve as an acceptor of more and more glucose from UDP glucose to form the fully formed glycogen molecule. It acts as an enzyme that forms a short glucosyl chain. We can say that the glycogen primer, it simulates an enzyme. It acts like an enzyme because it attaches the glucose molecules together. Now after the attachment of the UDP glucose molecule to the glycogenine, now we can elongate the molecule and form a larger and larger chain and a branched chain of glycogen. We can elongate the molecule after this. So the first step is attachment of the UDP-glucosyl residues to the glycogenine. Then the glycogen synthase can elongate the molecule more and more. يعني بعد ما ال UDP-glucosyl residues اللي هي كام واحدة دول مسكوا مع البرايمر، نقدر بعد كده glycogen synthase يعمل elongation. يعني elongation يكبر المولكيول أكتر وأكتر، يمسك في البريفري more and more UDP-glucose. زي ما انتوا شايفين ادي glycogen primer اهو. Like we can see here, this is an illustration of what I've just said. UDP-glucose. Okay, this is the UDP-glucose. Okay, and this is the glycogenine. Okay. First, this UDP-glucose are going to attach to the glycogenine primer. Then glycogen synthase is going to bring like 13 or more and more UDP-glucose molecules, and it's going to elongate the glycogen molecule. يعني بتبتدي بحاجة صغيرة عبارة عن شوية UDP-glucose مع الجلايكوجينين. الجلايكوجينين كأنه بيشتغل كإنزيم، هو اللي هيمسك مع few UDP-glucose molecule. طبعا ال UTP بتطلع بره، يعني ال UDP دي ما بتبقاش موجودة بعد كده، دي بس بتدخل الجلوكوز وتخليه يمسك مع الجلايكوجين برايمر، بعد كده بتبقى ريسايكلد، مش عايزها خلاص، دي بس فور ذا بوند. طيب وبعدين الجلايكوجين سينثيز بقى يجي ويعمل elongation. يعني احنا زي ما قلنا انه ما بيقدرش يبتدي لوحده، لازم حد يبتدي له، هو بعد كده يجي يكمل بقى يحط more and more glucose molecules. So what's the metabolic importance of storing glycogen? Okay, let's say first the percentage of glycogen which exists in the liver and in the muscle. We have almost 1 to 2% of the muscle mass is formed of glycogen, stored glycogen, and nearly 10% of our liver mass is in the form of glycogen. Okay. But since we have much more muscle mass, so this means that our muscle store most of our glycogen molecules. يعني طبعا احنا عندنا mainly ان الجلايكوجين stored mainly في الليفر والمسل. تقريبا الجلايكوجين بيمثل 1 to 2% من المسل ماس و 10% من الليفر ماس. but طبعا since ان المسل عندنا البلك بتاعت المسل، لما نحسب كل المسلز الكتل العضلية اللي عندنا في جسمنا نلاقيها اكبر بكتير من حجم الليفر لوحده، فده معناه ان احنا العضلات بتاعتنا بتخزن كمية جلايكوجين اكتر بكتير من الليفر، though ان الجلايكوجين بيمثل في الليفر 10% من الويت بتاع الليفر و 1 to 2% من المسل، بس المسل البلك بتاعتها في التوتال بادي اكتر من الليفر، فبالتالي الجلايكوجين في المسل much more than الويت بتاعه much more than in the liver. تمام. طيب ايه importance, what's the metabolic importance of storing glycogen? To provide a stored form of glucose that can be rapidly mobilized. يعني عشان يبقى عندي source of glucose مخزن اقدر بسرعة ان انا احوله لجلوكوز. انا مخزن الجلوكوز في صورة جلايكوجين، وده source سريع للجلوكوز، ده source يرفع لي البلاد شوجر بسرعة during the fasting state. Since diet is not a continuous reliable source، احنا مش على طول بناكل. That was glycogenesis or glycogen synthesis. طيب الجلايكوجين molecule اللي هي بتبقى stored في well fed state و under the effect of insulin، ولازم يبقى عندي excess glucose، ده اسمه glycogenesis. So glycogenesis, let's revise, it takes place during the well fed state when we have enough excess amount of glucose and we can store it in the liver and the muscle, and this takes place under the effect of insulin, the hormone of the well-fed state, which stores our glucose, our excess glucose in the form of glycogen, mainly in the liver and in the muscle. Okay, what about when we fast? When we fast, we are going to break down this glycogen back to glucose, because the aim of storing glycogen is to have enough glucose during the fasting state. So during the well-fed state, we store glycogen by glycogenesis. During the fasting state, we are going to break down this glycogen by glycogenolysis. Of course, glycogenolysis will take place during the fasting state under the effect of the anti-insulin hormone, glucagon, epinephrine. Mainly they act on the glycogen of the liver and the muscle, and they break down this glycogen to glucose in order to save our body, in order to save us from hypoglycemic attack. And this is the rapid source which elevate our blood sugar during the fasting state, during the early fasting state. الكيميكال نيتشر بتاعته هو جلايكوجينين هومودايمر جلايكوزايليتد بروتين، يعني هو عبارة عن بروتين هومودايمر 2 بوليبيبتايد زي بعض بالظبط وماسكين مع جلوكوز، فعشان كده اسمه جلايكوزايليتد جلايكوجينين. It serves as an acceptor of glucose from UDP-glucose. زي ما اتفقنا انه من غير البرايمر مش هينفع ان احنا to build up الجلوكوز molecule de novo، لازم الجلوكوز يمسك في حاجة already موجودة. So a glycogen primer or glycogenine is very important to serve as an acceptor of more and more glucose from UDP glucose to form the fully formed glycogen molecule. It acts as an enzyme that form a short glucosyl chain. We can say that the طيب احنا after we break down our glycogen molecule by glycogenolysis, okay, the glucose is released in the form of glucose 1-phosphate. Okay, so after the action of phosphorylase enzyme, on glycogen molecule, the glucose is released in the form of glucose 1-phosphate. Okay, this is the end product of glycogenolysis. Glucose is released in the form of glucose 1-phosphate. Okay, glucose 1-phosphate will be acted upon by phosphoglucomutase enzyme to glucose 6-phosphate. This is a reversible enzyme. It can convert glucose 6-phosphate to glucose 1-phosphate and glucose 1-phosphate to glucose 6-phosphate. طب why do we convert glucose 1-phosphate to glucose 6-phosphate? Because we want to take this glucose outside the cell in the liver. If this glycogen is stored in the liver, we want to take this glucose outside the cell. So we need to convert it from glucose 1-phosphate to glucose 6-phosphate. Then we need finally to remove this phosphate in order to liberate glucose outside the hepatocyte cell membrane to the blood. Okay? يبقى احنا علشان نخرج الجلوكوز ده بره للدم لو احنا في الليفر يبقى لازم نشيل الفوسفات دي، فلازم بحول ال1 فوسفات ل6 فوسفات الاول عشان الانزيم اللي بيشيل الفوسفات اسمه 6 phosphatase. The enzyme which removes phosphate from glucose 6-phosphate is called glucose 6-phosphatase. Okay? So that was glycogenolysis, which takes place inside the cytosol of the liver and the muscle. طب, is there another place where we can degrade our glycogen? Yes, we can degrade glycogen as well inside the cell, inside the lysosomes. We have a lysosomal enzyme which degrades glycogen, which is called lysosomal 1,4-glucosidase enzyme. So this enzyme is specific for the lysosomes and it's present in the lysosomes in order to degrade small amount of glycogen. Deficiency of this enzyme lead to accumulation of glycogen granules in the lysosome, which is called glycogen storage disease type 2 or POMS disease. This disease affects the heart. It affects the lysosomal enzyme of the heart. The lysosomal enzyme of the heart is absent, and thus glycogen in the lysosomes of the heart will accumulate, leading to heart failure. And this is one type of a glycogen storage disease. We are going to explain this diseases later, but we are explaining here as well. يبقى في كمان degradation بيحصل في اللايزوزومز، مش بس في السيتوبلازم، مش بس في السيتوبلازميك جرانيولز اللي متخزن فيها الجلايكوجين، لا في كمان بيحصل degradation في اللايزوزومز بتاعت الهارت، بتاعت كل السيلز بإنزيم اسمه جلوكوزيديز ده بيعمل degradation للجلايكوجين اللي في اللايزوزومز بتاعت كل الخلايا. ممكن يبقى defective الانزيم ده genetically absent especially في اللايزوزومز of the heart، ويعمل لي نوع من انواع الجلايكوجين ستورج ديزيز اللي هو تايب 2 اسمه بامس ديزيز، وده بيحصل معاه heart failure. ده نوع من انواع الجلايكوجين ستورج ديزيز لسه هنقوله بعدين، بس يعني بنقوله بالمناسبة انه بنقول ان في انزيمز موجودة في اللايزوزومز برضو for degradation of glycogen. ده طبعا بقى الباثواي بتاع الريجوليشن ده we will discuss it in the second part of the lecture. كده احنا almost the first part of glycogen metabolism خلص، وهنقول بقى regulation والglycogen storage disease في part 2 of the lecture.